Hi everyone, welcome to Mr. Cooper's YouTube channel. Here we're going through the Unit 4 of A-Level Product Design, PG Online Performance Characteristics of Metals. What we've got here is the assessment test again, and I've chosen to show you the mark scheme this time with the right answers in red and the amount of marks shown in the brackets over here. So select one of the following properties that can't be enhanced with case hardening. And if you remember, case hardening basically is putting a thin layer around the outside of a bit of metal or an object, if you like, and it would give it a thin skin that would just be kind of like that, just around the outside, just that thin layer, a fraction of a millimetre around the outside, leaving that internal part there nice and soft to withstand any twisting or torsion or bending forces that you could apply. So a property that can't be enhanced with case hardening is malleability, the ability to bend it. Corrosion resistance, you put a skin of hardened material around it, it's going to stop it rusting, etc. Hardness, obviously you're hardening it, so that's that one. A fatigue strength, you're going to make it more resistant to fatigue. So and some malleability, and it's a case of just working that through. You've got about a mark a minute here, so plenty of time on this exam and your final exam to kind of really take your time. Which of the following statements about low carbon steel is false? And it's always a real key one to kind of highlight the key words here, low carbon steel and false being the big one there. So let's make sure that we've got that highlighted. Low carbon steel is magnetic, that's true. Low carbon steel is easy to weld, that's true. Low carbon steel has a high melting point, it's around 1600 degrees Celsius, so that's true. Low carbon steel has good corrosion resistance. Well, we know that that's not true because it rusts quite easily. Okay, so that's the key one. And it's a case of just working those out. Low carbon steel is often called mild steel. Okay, so it's worth knowing the other name for it if you like. Describe why metals are good conductors of heat and electricity. 1 mark for a relevant point, a further 1 mark for a suitable explanation, up to a maximum of 2 marks. Metals are made up of atoms that are tightly packed together, would give you 1 mark or something similar to that statement. You don't have to get this word for word, but just saying the same kind of thing. Exist as positive metal ions surrounded by a sea of electrons that can move freely, to give you another mark. The strong electrostatic attraction between ions and electrons mean the free electrons can move through the metal, allowing electricity to pass through metals easily. 1 mark. It's a kind of a good one to kind of try and remember a key way of writing that, I think. It's just one of those that you're going to have to know, okay, and kind of look at how that's written and what you really need to write for that, okay, because it's quite a good question. Why are metals good conductors of heat and electricity? So we need just a couple of statements there. Okay, if we go on to number 4, 2 ways in which the hardness of steel can be altered using heat. 1 mark for a relevant point, 1 mark for a brief explanation of the process, up to a maximum of 4 marks. We've got 6 marks for the question, so we're looking for 2 things to be highlighted really. 2 ways. So hardening steel, so medium to high carbon steel, we can't do that with low carbon steel or mild steel, it's not got enough carbon in it. Heated up to around 7,000 degrees, that should be 700 degrees C, and quenched immediately in water or oil, making it harder but more brittle. Okay, so if you harden something, it's going to become brittle, and that's one of the problems you get with it, so show an awareness of that. Tempering then is taking out the hardness but increasing the toughness. So you could temper it and alter that the structure. Hardened medium to high carbon steel is heated to between 220 and 300 degrees C. Reduces the hardness in some parts of the steel to increase toughness and reduce brittleness. Okay, so it's a nice one, tempering, to remember. Case hardening, you've already been asked about case hardening. But involves heating low carbon steel to a dull red colour, around 600 degrees, 700 degrees, somewhere around there, dipping it in a carbon compound, so carbon rich powder, adding carbon to the outer surface, it gets burnt to the surface and making a soft core. Okay, so pretty much like I've described in that first question for you. Annealing steel's heated to be around a cherry red colour, around 725. I don't think you need to be too specific with that. It's just showing an awareness of roughly where it is. Then cooled slowly, which removes the internal stresses and increases malleability. So annealing is done in either a heat-controlled oven or put it in some sand to allow it to slowly cool down. If you did it in air, it would rapidly cool down, and we don't want that one. Normalizing, heated between 7 and 900 degrees, held at this temperature, called soaking, which removes the internal stresses. So all the kind of pressure that's been applied to it, releases those stresses, improves the overall strength, hardness and structure. Okay, so normalizing is quite a nice one to talk about. Me personally, I'd talk about hardening and tempering. Okay, I know about those ones. I can talk about those with temperatures and things like that. I could talk about case hardening. It's a nice one for things like chuck keys on the lathe, where we've got an object such as my pen. It's going to go into a hole, and the outer skin of it is going to be hardened, but the inner skin would be kind of left natural. Okay, so it can withstand that twisting force. Let's look at the next one. A designer has selected aluminium for the manufacture of a caravan. State 2 material properties that make aluminium suitable for this application. Okay, 1 mark for each correct answer. Simple as that. So it's got excellent strength to weight ratio. Okay, it is lightweight, but it's very, very strong for its weight as well. Good resistance to corrosion. We know it doesn't rust. It doesn't need any finish applying to it. It's malleable, so it can be folded, bent and beaten into shape. It's easy to work, easy to drill, machine, cut, etc. Low density, can be anodized to give it a nice finish to prevent further corrosion. Okay, so quite nice, easy ones there for us. I say easy, it's only easy if you know the answer, but that's what we're trying to work on. Study the image of the tubular frame chair pictured below. So the tubular frame is on the arms that kind of folds around, bent in several angles, and would be welded into place. Explain 2 reasons why the wall thickness of the tube should be considered when designing this product. 1 mark for each correct answer up to a maximum of 2. So we're looking for 2 lots of that basically to give us the 4. So the strength then. So we're going to consider the strength of it. Too thin and it won't be able to support the required weight. So we're justifying it with what we're saying. Weight. So if you make it too thick, it's going to add the weight. It will be excessively heavy to manoeuvre. So moving it around, lifting it, etc. Cost. If it's too thick, there's more material there. It will be expensive and it'll be a waste of money. Okay, there's no need for that. Flexibility. Too thick again, and we lose that flexibility, that kind of bounce and that kind of flex it's going to have on it when that person sits in the chair and bounces up and down. Wouldn't flex and would be more comfortable. It would be very rigid, very stiff to sit on. Okay, and another mark for that one. Following questions about testing materials. Oops, I'll just move that up. State 1 test used in industry to determine mechanical properties of metals. Give the mechanical property that the named test measures. So award 1 mark for a relevant test and a further 1 mark for the correct properties tested, up to a maximum of 4 marks. Except alternative industry test if named with correct property. So you've got the IZOD impact testing, which is about toughness. Rockwell, Brinell or Vickers hardness testing. A bend test to test the malleability. Tensometer, which is that machine that pulls the metal apart, and that's the tensile strength testing. Okay, so it's just a case again of remembering the hardness testing ones. Okay, one of those maybe that you can remember. IZOD for the impact, which measures the toughness. So if something's bashing into it, it's the toughness. Bend test, which is simple malleability. And tensometer to measure the tensile strength testing. Describe using notes and annotated sketches how to carry out an electrical conductivity test on a range of metal samples in the school workshop. The key bit there being a range of metal samples. Okay, electrical conductivity we're looking for here to get between 5 and 6 marks. You can see you've got that kind of working scale. We work up. I always start at the top and write what do we need to kind of get in there. Looking down to you've either written nothing or there's diagrams fully clarifying the correct stages, considering an electrical conductivity test that could be carried out in the school workshop. Okay, so we're looking at some kind of comparative testing here, electrical conductivity carried out in the school workshop, so it needs to be relatively straightforward. If I click onto the next sheet, that shows us our picture, our diagram of the kind of thing we should be drawing with a multimeter, 2 probes, test piece, and then we're kind of reading out what kind of conductivity reading we're going to get. Okay, and then it's a case of comparing those ones from one to another. But the indicative comment, that's basically the comments that we could be writing, reference to the test piece being identical size. So whenever you're doing a test, it's important that your test pieces, your specimens as they're called, are at the exact same size, so the same length and the same thickness, okay, much like my pen. Reference to 2 probes of the multimeter being set at identical distance apart on all samples. So that's the key bit. We've got to make sure that that's the same, the thickness of the metal is the same, the length of the metal is the same. Okay, so we're keeping all those variables the same. Reference to no oxide layer on the surface or clean surface. Okay, so it's going to not inhibit any of the testing. Correct use or settings of the multimeter to measure the resistivity across the samples. Mention of lower resistance means better conductivity. Okay, so it's kind of showing that you understand that the more electricity flowing through it means it conducts electricity better. Alternatively, measure current and voltage and use Ohm's law of V equals IR to determine resistance in a sample. Okay, so just showing your application of scientific knowledge and math knowledge in there. Samples needs to be set on non-conductive surface, so something like a wooden bench would be ideal. So it's not increasing it or decreasing it, or skewing the results, if you like. Another nice one here, study the image of a trumpet, a musical instrument made from brass. Just in case you didn't know, it shows you a picture. And it's the kind of thing that you get in the exam where they will give you a picture and a description and some kind of explanation from it as well. Discuss the working properties of brass, why it's suitable material for the manufacture of the musical instrument pictured. So again, we're looking for this sliding scale down to nothing, all the way up to 5 to 6 marks, which is where we want to be. A full and informed discussion taking many fully explained factors into consideration. So it doesn't tell you how many, it's that kind of gut instinct, taking many full explained. I'd probably be looking for 3 or 4. Discussion should be appropriately justified, showing an excellent awareness of why brass is suitable metal or material for manufacturing musical instruments. And down here we go down from taking many to covering several relevant factors. And I'd again probably be looking at 2 or 3 there. Okay. Going lower down, it talks about a listed point rather than a kind of a coherent discussion. So if you bullet pointed it, you're going to do well to get above that, really. If you write your bullet points well and they're well considered, I'd be moving it up anyway. But that's probably why that one's written. Okay, so if I flip that one over, so the indicative comments to look at here. So brass is durable, so the instrument will last or be able to withstand daily use when in contact with skin and moisture. So the moisture on your skin, the oils on your skin, the moisture from your spittle that will come out of your mouth when you're playing this instrument isn't going to tarnish it. The moisture on your skin will damage the lacquer and the brass, causing it to tarnish and go dull, so it needs cleaning. Low coefficient of friction, self-lubricating is a quite nice one, so valves can slide up and down and produce different notes efficiently. So the valves are pressed down to give you a different note, and you can get a variety of different notes by doing that. But that needs self-lubricating. You can't be oiling it all the time, for example. Available in tube section. So if you don't know what a tube section is, it's something like that. Okay, so it's not solid, it's got a hole in the middle, tubular, a bit like a I don't know, Smarties tube, if you like. Vibrations from the mouth can be amplified into sound, so it's a sonorous material, as we call it. It says down here, brass has excellent acoustic properties, or a sonorous metal. Corrosion resistance will be able to withstand application of a variety of lubricants and moisture, humidity from the skin. from daily use and maintain a sleek aesthetic look. Okay, so again, it's quite a nice metal to look at, and it's got various properties in that way. Malleable, so it can be easily formed, spun into different sections to create different pitches. Okay, so the idea of spinning it to create the bell of the trumpet, it's on this sheet, sorry. This bit here would be spun, okay, and it's normally joined here onto the other tubes, but that's done on a machine and it's called spinning. It's almost like a lathe. Without cutting it away, it's pressed and formed using a roller and it's kind of shoved into place. Well worth looking at spinning, a very old-fashioned process, but still used for things like that, lampshades, etc. Cast easily, machined easily, brazed, so complex components can be accurately manufactured and connected, maintaining high tolerances required for instruments to create consistent sounds. So it's a nice material to machine, to join, etc. Brass has good acoustic properties of sonorous material. Okay, so 6 marks in that one. Study the images below for the different pans. So we've got a copper pan here, where it helps being in colour. You can see you've got copper fittings, copper handles, or some brass handles. It looks slightly different to the copper, but it doesn't matter, it's still a metal. The advantage of that, not a plastic handle that you get, it can go in the oven. Okay, so you can put that straight into the oven, and similar with a stainless steel pan. Now, both metals are very, very good at conducting electricity, so either of them would work. The copper probably looks nicer, but again, that's just a personal opinion. Stainless steel isn't going to stain. It's made from steel, so we know it's got some ferrite in it, some iron ore. So if we weren't having the stainless ability with it, it would rust. So looking at material properties, health and hygiene, ease of use in a kitchen environment. And again, it's that sliding scale. So response demonstrates a thorough understanding of the suitability of each cooking solution. The discussion should consider at least 3 reference points showing an excellent awareness of how the 2 products compare. So we've got that kind of mixture there. Then we're looking at 3, we're looking at 2, we're looking at 1, or very little down to 0. Okay, if I flip that onto the next page, we can look at our indicative comments. So we've got copper is an excellent conductor of heat, quickly get to the temperature required to cook food. However, the handle is likely to heat more than the stainless steel pan handle. Okay, so it's going to get really hot really quickly. Copper is very, very malleable, very easy to form and shape, more expensive than stainless steel, but it's more efficient at conducting heat, so it could save money in the long run if the use of gas or electricity in cooking. Copper is not magnetic, so will not work without additional materials being included in the pan on induction hobs. So induction hobs kind of switch on when it's got the kind of metallic materials on it, so it switches on. It's quite safe with heat then. If used in its pure form, copper is relatively easy to recycle. It's cheaper to recycle old copper than extract new copper. Copper is a naturally hygienic antimicrobial material. It's been proven to slow the growth of bacteria such as MRSA. Okay, so that's quite a nice one. You get those bracelets made from that to kind of get rid of these bacteria and what have you. Natural corrosion-resistant material does not require additional finishes, meaning it can be washed in a range of detergents without deteriorating. However, if left, it can form an oxide layer, so you can get slight kind of discoloration. Relatively soft for a metal, so may dent and damage easily if knocked when in use or during washing. Compare that to stainless steel. You'd be expected to know a few of those. All of them is quite a push, so don't worry about that. Stainless steel very hard, so it will resist scratching and ruining the surface of the material when washing and scrubbing clean with abrasive pans. So pads, sorry, not pans. Quite useful for when you're cleaning it with your kind of wire wool wash pads that you can get to get rid of burnt on marks, etc. Stainless steel is hygienic, does not adversely affect the flavour of food even at high temperatures. So you could get that kind of metallic taste into your food if you weren't using stainless steel. It's tough, so it will withstand being knocked in cupboards or dropped on the floor. Try not to just write the opposite of what you've written for one material there. Okay, you won't get doubly marked for that. Stainless steel has a great corrosion resistance, so it can be washed with harsh chemicals, while retaining its original properties. So you're not going to wear the kind of stainless nature away from it. It's also magnetic, can be used without the addition of extra features in order to use on an induction hob. So you could get a stainless steel saucepan with a copper base on it to give that extra conductivity of heat, etc. But then also to be able to be used on the induction hob. Recycling steel is less expensive than extracting new iron ore, so it could be sustainably sourced from recycled steel. Okay, so a nice way of thinking about that. So the recycling is a lot better for the environment and cheaper way of doing it. Questions about heat treatment of metals. Chart below shows the different colours of steel after tempering. Label to indicate on the chart where the following items would be tempered to. And for me, if you've got these in the right order, roughly in the right place, then that's fine. I wouldn't expect you to know exactly that Latals are 227, but if you've got these in the right order, so we're looking at kind of hardness up to toughness up here. Chisels being splat bang in the middle needs kind of a best of both worlds. Two pieces of the same size of high carbon steel are being tested for toughness. Sample A has been heated to 700 degrees Celsius and quenched in water. So we know that that one straight away hardens. Okay, so heating up and quenching hardens it. Oh, let me just move that up my screen, sorry, I do apologise. Sample B has been heated to 700 degrees, so it's hardened it again, it quenched and then reheated to 300 degrees Celsius left to cool in air. What's that reheating called? Well, we know that that's up here. That's the tempering. Okay, so if we temper in it, we're going to make it somewhere up here, yeah? So it's around that kind of temperature and that kind of colour up here, right up at the top. Okay, explain which sample will have greatest toughness. So toughness up at the bottom, hardness toughness at the top, hardness at the bottom. Greater toughness for a suitable explanation up to a maximum of 2 marks. So we should be saying sample B is tougher. It's been tempered, which increases the ductility, reduces the brittleness, therefore increasing the ability to absorb impact. Okay, so we'll be taking out that brittleness, we're increasing the ability for it to bend, but making it also have the ability to absorb impact. Why is that? Well, we took the brittleness out. If it was brittle, it wouldn't absorb impact. Okay, sample A will be more brittle despite being hard, as it was quenched immediately. Quenching immediately is going to kind of crack it and make it go very, very brittle. Therefore, sample B will be tougher. And quenching it immediately makes it kind of glass-like, if you like. You know, that's a very hard material, glass. You can't scratch it very easily, but if you tap it, you're going to break it. It's very brittle. Okay. And just checking, yeah, final question. So question number 11 then, evaluate the use of tin and gold in electronic printed circuit board connectors. In your answer, consider the following points: material properties, environmental factors and ethical implications. And I'd be looking at you writing a bit of a kind of write-up about this one, making sure that we're ticking off, we've talked about all of those, and then saying which one you think is better because such and such. Okay. So a full and informed discussion taking many fully explained factors into consideration. Discussion should be appropriately justified, showing an excellent awareness of many points mentioned with regard to both gold and tin, including the implications of sourcing and recycling both materials. So that's your environmental factors. Okay. Ethically, where we're getting it from, how's it going to be sourced, maybe. Material properties, well, there's your easy one straight away, so we can talk about the types of materials. Okay, so let's go through these and we'll discuss as we go along. So the advantages then: tin has a low melting point. It's around 250 degrees, I think, from memory, and therefore requires little electricity to heat and melt into solder to join componentry in electronics, or components, I'd have said. The low melting point means it's unlikely to damage other components when it's attached to them with heat. If you think of steel being 1600, tin being at 200, 250 degrees is really low. Tin is soft and malleable, so it's easily drawn into wires, perfect for soldering. Tin has good corrosion resistance, and such the electrical contact will stay clean, signals and will not deteriorate over time, staying efficient and reliable. Again, you've not got to write this word for word, it's just showing an awareness of the properties, the answers that they're talking about. Gold is very malleable, so it can be formed into very thin sheet, used to coat the surface of circuitry and components, increasing conductivity. So it's another great one for gold plating, silver plating, etc. So making it very thin because it's so expensive. Okay, you could coat the surface of it and then increase the conductivity. Brilliant conductor of electricity. Gold is an excellent conductor of electricity, will therefore increase the overall performance of electronic systems as signals are clearly and efficiently connected. Gold can be easily electroplated onto cheaper base metals, saving money whilst keeping a high quality connection. Okay, so that some of the higher end jack plugs and audio connections are going to be made from gold plating, and that's electroplated on top. Excellent corrosion resistance and is inert, so it won't corrode over time, resulting in a durable system, increasing the longevity of the product. Impervious to air, water, alkaline and most acids, so even in the most adverse conditions and with exposure to moisture, performance will not degrade. Gold can be recycled with no degradation in quality. Recycled gold can be used in electronics, reducing the overall environmental impact of using the metal. So obviously very difficult to find or find in quantity, but you can recycling. There's lots of these places that will take old gold and recycle it for you. Companies are starting to be more ethically responsible, starting to invest in ethical gold sourced from responsible sources that have been verified to have the best practice, environmental and social standards. Okay, so it's now gone as the day where we try and find it in the cheapest way. We're now trying to do it in the most kind of responsible method for the planet and for the environment. Okay. Disadvantages then, let's go through these. Tin is sometimes used in a paste form, alloyed with other metals in soldering components. It can be difficult to recycle, so if you're mixing it with other stuff, you're going to struggle to recycle it. Difficulty involved in recycling tin results in raw tin resources depleting in an unsustainable way. Okay, but because of how we said that mixing makes it better, it's more likely that you're going to need the raw tin in its kind of original form. Whilst tin is able to be recycled, it's lower than most other metals and is a relatively scarce element. Okay, fair play. Tin plate scrap cannot be reused to make tin plate due to its impurities. Okay, so it's got to be quite pure metal to kind of be reused again. Because of the extensive use of tin in electronics, those in mining it are paid low wages and subject to harmful working conditions. Quite an old-fashioned view on things that, but probably still prevalent at the minute, sadly. Due to the disposable nature of electronic products and relatively high value of precious metals such as tin, gold, recycling electronic waste often involves burning, grinding, washing, bathing in acid in hazardous conditions, releasing hazardous fumes for those working to recycle e-waste or electronic waste. So it's not a nice way of doing things. It's not particularly healthy way of doing things, but it's certainly something that we have to be aware of, how it's disposed of and how it's recycled. Okay, so that test there is out of 50 marks. Just building up our stock knowledge of how to answer these questions, how to see it on the mark scheme, see what the examiner or the marker would see from my perspective, and what they'd be giving you marks for, and kind of not taking marks off, but be expecting you to be writing. Okay, I hope that's helped and given you some ideas on where to go with the answers on the metals side of things. Again, if you need any help, please get in touch with me. Like the video, subscribe, put some comments in, whatever it takes, and I'll try and get back to you if I can. Alright guys, thank you for watching. Have a good evening. Bye-bye.